Hey guys, back again with another video on the 200 amp power supply. So this is the control board I've been working on. Try to get that all in one shot. So it's quite a lot going on here. Start down here. Let's go up here to the top actually. So first off, this wire right here is just connected to a 12 volt power supply right here for testing. So these 5 right here. These 2 are actually reversed when I wired it, so I just renumbered them properly. And so this one right here, it's been a long time since I did this, so if I remember right, this one's the pressure switch override. So normally you have a main key switch, but if you use the pressure switch, it will override it, so if in the remote situation. So as of right now, I may not even use this, as well as this one. This one is the lockout functionality, basically, so if you want to, you can lock out the main system, and this will prevent any voltage from being applied to the coils or wipers of these 3 relays. These 3 relays are, this one receives power from, I'm trying to think. Sorry if I'm drawing a blank on a lot of this. I literally spent like an hour or two figuring out what exactly this did because I designed this 2 years ago with a really crappy schematic. And if you ever know what it's like to go back through your own work several years later, and you've learned a lot since then, and you are not paying much attention when you're making it, you'll understand what I mean by that. But basically, if I remember right, so if you actually, a lot of this you can actually trace back wiring. So this relay gets its power from here. So power will come in. Normally, it'll just come straight to here, and it will bypass this. This is actually, it is normally open right now, but basically the key switch will bypass it and apply power to the coil. Will bypass it and apply coil straight to here. Or the pressure switch will bypass and add coil straight to power straight to the coil there. Or if the key switch is on, it will apply power straight to there. And then the wire will come out, and then it will power. Actually, yeah, sorry, I'm like really brain dead today. So this would come out to the key switch. That goes out to the key switch. This red one here comes back around into the coil, or not coil, into the wiper of number 2. And that's the lockout relay. So obviously you can see it's not connected because there's the coil. The wipers are down here. Coils are on this side. Normally closed is on the top. Normally open is on the bottom. If you can see that a little bit better. So you can actually see the numbers. So 8 and 7 are the wipers, or 8 and 7 are the coil. 6 and 5 are the wipers, and all the other numbers. So top side normally closed, bottom side normally open. And so basically you would have, this would be, man, I really need to like pay more attention when I'm actually going through, because I actually redid a whole new schematic for it, and the schematic makes sense if you actually know how I write things. But basically this wire now will keep constant power. Once this relay is on or key switch apply power is there, power will go straight to this relay, basically ignoring the fact that it's there, coming out into this relay. And this relay will get turned on when you have, I think it's when you turn on the cover switch. This relay would turn on, and then when you press the engagement, this relay and this relay, when you turn on the on button, these 2 will latch down. When you press the off button, these 2 will unlatch, and then you can turn off the cover switch. And then if you turn off the main switch, all of these will shut off, or if you turn off the cover switch, all of these will turn off. Basic functionality. So that's all it does, is lock out the rest of the system when it's not on, so none of these relays have power. These 3 banks here are basically mirrored images of each other. There's a lot of wires coming out of the output. All these go straight to terminal block, ready to go out, basically for future proofing. So if you need multiple outputs, I've got them ready. They all come to this terminal strip right here. So let's see, we're already at 4 minutes. I only have about 10 minutes per clip. Each 10-minute clip is literally like 3 gigs long, or 3 gigs in file size. So I try to limit it, but basically, so I actually have it out because I've been testing, and it's normally closed. So basically power goes straight through it and makes testing a little bit harder. But this is the lockout relay. And so basically, like I said, it locks it out. So if this bank is on or this bank is on, this will be locked out, so on and so forth. So then power will come into here. These two right here go to the lockout controls, which are right here, which is just a bunch of diodes, basically keeping things from turning on other relays when they shouldn't. It's kind of difficult to describe. So basically, when this relay number 2 turns on, it goes into a diode, and then the diode keeps it just going in one direction and turns on the coils of these two relays. Simple as that. Relay number 2 here is the latching relay, and that latching relay has an on and off switch. And then relay 3 here is the main control relay, so it's completely separate, and it's actually, or it may not even, it may have its own, I think it has its own wiper voltage and wiper outputs. So if you need to run 120 volts through there, you can, but I will only be running 12. And so that's the gist of how those 3 work. They're all, like I said, completely mirrored, so it doesn't matter. Basically, the idea is this is the main control. This is 120 volts coming out. This is 240, and this is 480. So I'll have a set of transformers. This will be a straight pass-through 200 amp contactor. This will probably be a 50 amp contactor for 240 volts, and another 50 amp contactor for 480. And then down here is the output view. And so my dog likes to find the mice that are in my shop. That's all the noise in the background. This is the output view. And so all it does is it switches the voltage from the output meters from before the contactor to after. So if you want to know what it's at on the variac stack before it goes out, this will allow you to show that. And so very simple. It's actually, this concept right here is based off Photonic Induction's 20,000 watt power supply, because it's a really cool power supply. But I also added a lot of my own features, kind of added some other features from his, what he called the Big Boys power supply, which had the ballasting circuit, which this will have as well. I just have to build that on a separate board. But this is the variac control right here. So this is switching between forward and reverse. This is power. So normally closed is forward. So whenever this turns on, it'll be automatically forward. But if you want reverse, you'll turn both of these on, and then you'll have reverse. These are the control relays. So this is a locking relay or latching relay, and this will latch. So if you want it to be basically not momentary, so latching, you'll have this on, and then this relay, if you press forward, will latch. If you want reverse, you press this relay, it will latch. And the switches have both normally closed and normally open contacts. So when this one turns on, it shuts off this one. When this one turns on, it shuts off that one. Simple as that. And if this one isn't latched on, these will just be momentary. Simple. Basically, it's pretty simple the way that works, because the coils from here come straight out to power the relays, but the wiper gets ran through this relay. So when the button gets pressed, it only temporarily applies power through there, but if it gets latched, the power gets held. If you do want a more in-depth video on exactly how all this works, I will also make a schematic completely digitized, because a lot of these are madman scribblings, is what I like to call them, because they have them make not much sense, because there's a bunch of random labels that aren't used properly, because I went through and changed things as they go. There's a lot of pages of everything, and so like back here is most of the pinouts, but a lot of this has changed. That's changed. Half of the big terminal block has changed, so it's whatever. But basically, I did finish all this up. That is finished. This is finished. This, I think I got everything labeled now. Got about 40 seconds left. I may just make a whole new clip. Sorry about that. My phone actually overheated. It's like 90 degrees out here in my shop because I don't have air conditioning. So if I remember where I left off, kind of, sort of, basically, I want to, if I do end up making a more in-depth video of that, if you guys want me to, I will. And I'll just make all these proper and do them completely online. Probably just use Easy EDA or something and just design the circuit completely digital, so it's a lot more easy to understand. But basically what I'm doing is going through and figuring out where each of the pinouts need to go. So basically this is the prefix, so T2, so terminal block 2. which is this big terminal block. Pin 8 is the normally open contact. Pin 4 is the normally closed contact. The voltage in, so where I need to apply voltage for that relay bank, is pin 5. The voltage out to power the normally open and normally closed switches is pin 2. We have a lighting pin, so we can see if we want a light to know if that relay bank is on. That comes out on 3. The control common, so relay 3 is pin 9, and the outputs of that is pin 10, 11, and 12. Completely overly done. Doesn't need to be that many pinouts, but I'm designing it that way because I can, and I don't really have enough space. I'm using like 40 different connections here. That's the high voltage side. This is like a almost 40 pin long terminal strip. And there's another 12 or something pins right there. And then you got another 4 there and another, I think, 10 there. So there's a lot of connections, and a lot of these are going straight to the control phase. Meters are going to be up to 200 amps and up to 600 volts. It'll only be supplying 50 for this, but it's going to be designed for up to 200 amps, possibly more. But yeah, that's basically it. So these 3 are mirrored: main control, output view, variac control, and then I still have to build the ballasting circuit, and then I still have to build, well, I need to get all the ballast transformers together, but I got a bucket full of ballasts. There's my dog, thinking there's mice in there, because that bucket actually doesn't, because it was up in the garage up at the house. Actually, I'll show you that here in a second. And then I got a couple other odds and ends transformers over here that I can use. But these are the variacs I'm going to use. I'm going to buy 3 more of these probably. I literally ran 60 amps through this, and it's only rated for 30. And I had it going for a minute or two as long as that 20 amp breaker would hold, and it didn't even get hot. It hummed a little bit, but that was only when I was in between contacts shorting them out. So if you get it just right, not in between a contact, she runs happy like that. I know it had to be about 60 because this was completely tapped, and judging by the actual output voltage and the fact that this number 14 wire was getting warm enough to actually be able to get very pliable, suggested it was probably around 60 amps going through that. And if I actually had a clamp meter on it, it would probably show 50 to 60 as well. So just a guess, but yeah. So yeah, my phone gets hot very fast out here. But yeah, so I want to do 3 of these. I want to stack them. There's already kind of holes in the corners for it. And then stack 3 of them. I'll have to thread it, make a proper rod through it all. And then I'll have to make ballasting I forget what they're called, balancing chokes. Basically, there's a phenomenon in electronics where basically one variac could be taking twice the load as the other 2, and so those balancing chokes will be forcing them all to share the exact same load. I'll have to design that, but that'll be worth it. So this will probably be put vertical in the back of a cabinet, and I'll have to build the cabinet too. Don't know what I want to build it out of yet. Most likely I'll try to get a metal cabinet that'll fit it, but they're expensive. I know, because I'm an electrician. I do control work. I know they're expensive. But yeah, so I got to get a motor for this, a reversible AC motor, so I need to have one that has the capacitor, because basically induction motors can be reversed as if you lag the current behind the voltage, it'll go one direction, or if you put the current in front of the voltage, it'll go another direction. That's my understanding. I don't remember if it's quite correct or not, but you use a capacitor to do it. Sorry if I'm talking really fast. I'm just trying to compress all this into one decent video to give a general overview. But yeah, so that's where you can see the number of wires that have to come through all these channels. That's about everything pretty well good. So I have a lot to. I still have to finish the other 3 and figure out where their pinouts are. And then there's the main circuit. Good luck reading that if you want to try. There you go. And there's the ballasting controls. So these will all be latching switches to change whatever you want for voltage, power, and then you can control them out there. Let's see, there's a couple. That was the general idea for the main power side routing, but I'll probably change that up a lot. This was done 2 or 3 years ago, or 4. I started this like 4 years ago just as a concept. That was the general layout of the face, but this is going to get redone again because I redo everything several times over before I finally settle. And that's the generalized for all the ballasts. So you have 6 different relays on here, and then you have an auxiliary relay, which will bring in an auxiliary ballast, and then you have a main bypass relay. And I say relays even though those are all 50 amp contactors. But yeah, that's about it. That's this entire book full of information on this is 30 to 40 pages long of just stuff I've written about this. But anyway, that's part 1.2, I think is what I'm going to call it, of this main control face, which is basically done. Just got to find out the pinouts of these 2 banks, and then I'll be done. All of that's figured out. From here over is figured out, and all of these are known because I just redid all of this. I just wired it myself because I decided I do not need to change the current monitoring system. So 5 relays to do that. If you want to actually know how to do this circuit, because it actually took me a minute to figure out a good way to do it, if you want to know that, I'll also put that in an in-depth video if people want to see that. If not, oh well. But luckily, I do have tons of control wire. It's all red though, but that's probably about 1,000 feet right there. And I've got a spool of purple up there, and that's all odds and ends and wire. That's like 50 or 100 conductor underground Cat 3. And that's 6 gauge, 6 conductor cell tower wire. There's 50 feet there. There's 2 more spools of 50 feet roughly under there. And that's what I'll be using for the hookup wire. So yeah, that's basically the idea of what's going to be happening. And there's really not much left to talk about. So I'm going to plan on ordering all the buttons and everything. Once I get all this finished, I know exactly what I need. I'll order all that. But besides that, thank you guys for watching, and I'll see you guys in the next video. Hopefully this one will actually come out within a week or 2 and not 2 years like I said last time. See ya.